And these are the things that, fortunately, I've been associated with in my career. This is particular mix. This is a conventional mix. There is nothing special about any recycling in there. But the way we came up with the design, selection of material, first you go to the laboratory, you evaluate what you think can be evaluated. Then, if you see that in one of those tables, then you could go and evaluate performance using the pavement ME or MEPDG. We have a good success with that. It offers a good quantitative measure that we have validated in the field from calibration. So you have that as a tool to compare what you want to do. And then finally, you evaluate the LCA through a tool that you have. And you could see the reduction in CO2, waste, and energy, and so forth that have yielded. And we took it out to the field. It's now in a specification. So there are things that you can engage state DOTs, industry, to have a successful implementation of those technologies. Second thing I want to go over is construction. And here is a typical layout of construction, basically what goes out in the field in a mixing facility. And you could see that we've got aggregates, and then you take the aggregate, you dry it, it goes into mixed with the asphalt, then produced and comes out. So there are a lot of energy consumed at all these parts that we're talking about. And the challenge is that, okay, how can we minimize that? And if you come up into this quantification, into all these components, what one finds out is that heating and drying the aggregate takes the most of that energy. It is something that simply we can do. It just have the willingness to do it. Covered stockpile. I was in China a couple years ago, and they've got very nice, huge covered stockpile. I'm not sure it's feasible or not. Contractor or construction industry can tell us. But one way to minimize this, you could see that. There is tools available to the industry, as you could see in here, to evaluate the type of energy usage, and then you can monitor and then decide what you want to do in order to minimize and be into the sustainable umbrella. And another technology from the construction side is warm mix asphalt. And you heard about that earlier. Warm mix asphalt basically means that you lower the temperature. And when you lower the temperature, that means you have lessened emission and environmental impacts. And you could see at the bottom picture, there is a one HMA with a smoke, and the one to the right of it, there is no smoke. And that tells the story about warm mix asphalt. There's a lot of interest in this technology. Many states is adopting it right now. Natural, sustainable, that could be used and evaluated. Of course, there are many tools, existing tools, that one can use and one can improve on in order to evaluate various emissions, energy consumption, water consumption, and so forth. One typical one is the plate in here, is a spreadsheet that goes from inception to cradle of the material of the evaluation for these different various components that one utilizes. And I think at the end of the day, it would be good if one can have some sort of a point system so that it makes it easy for an agency to translate, to assimilate, and to implement. We heard about LEED earlier, an example of that, but that needs to be translated into pavement. So that's something I think we should look at. But at the end of the day, these are the three things that we got to look at: performance, economic, environment. Which one is more important? This is something it's at the policy decision making with support from a technical data that can advance our mission. And finally, I leave you with your thoughts, and here is that. There are any challenges we can identify to advance sustainability. I think owner agency, designers, material suppliers, and contractors can advance the approach by adopting more sustainable practices. There is a large body of knowledge in there that needs to be synthesized, and also a communication of those information to the designer, to the construction, to the maintenance of these activities. With that, I thank you for your attention.
Next and last is Jim Musselman.
Thank you.
Want me to help you with this?
Yeah, if you would, please. Well, good afternoon. It's nice to be here in South Florida. I was actually born about 10 miles to the west, which I think is that way, so it's kind of neat to be back down here in Dade County. There probably aren't a lot of Dade County residents, so raise your hand if you were born in Miami-Dade County. Come on, be proud. There you go, quite a few. All right, very good, very good. It's nice to be here. Hisham has given me, gracefully, has given me about 45 minutes to come. He's given us 10 minutes, and the interesting thing about Hisham, he's a very good moderator. He told us up front, he's got a taser. And that if we go over the 10 minutes, that we will, quote, ride the lightning. So we're going to stick to the 10-minute thing. I want to talk to you maybe in specific terms. You've had a lot of good generalities up to this point about some of the things that the Florida DOT is doing in the area of asphalt pavements. Two specific programs. One was very effective. The other one wasn't quite as effective. So I want to kind of go through that real quickly. So again, it's a tale of two programs. One was market-driven. The other one was mandated. Hot mix asphalt recycling, you've heard about that through other speakers. In Florida, that started in 1977. It was a contractor initiative. They got together with the DOT and the FHWA bought in. They tried some pilot projects. Projects went down pretty good. Short-term performance was good. So by 1980, we had specifications that allowed the use of RAP, or reclaimed asphalt pavement, as a standard practice. The department looked at it at that time as the benefits being that the use of RAP, it conserved resources. It allowed milling, which is grinding up the old pavement without generating a waste. I think Jim Warren talked about that. We don't want it filling up landfills. And it also would save some money. And we thought that was a good deal. So since 1980, these are some ballpark numbers. The department estimates we've used about 150 tons of hot mix asphalt mixture, about 33 million tons of RAP. Now keep in mind, DOT usage in the state of Florida, I think this year we're about 39% of the entire statewide uses of asphalt is DOT. Some years it's only 25%. So you can at least double these numbers, if not triple them, for the county uses as well. The resource savings from the use of RAP, over 30 million tons of aggregate and 1.7 million tons of asphalt binder. That works out to be 12.6 million barrels of asphalt binder that we've saved since 1980. Bringing it closer to more recent terms, last year in fiscal year 2012-13, the department used about 5 million tons of asphalt mix. 85% of all those mixes contained RAP. The average RAP content in our mixes is 25%. Don't worry about the math, but you can see we used about 940,000 tons of RAP. We track those numbers pretty closely. And with the current material cost, aggregates somewhere, if we got a room full of aggregate suppliers, so I got to be careful what I'm saying, but aggregates somewhere in the $20 to $30 per ton, and that amount of aggregate we're saving, somewhere about $25 million worth of savings in the aggregate department. Binder is over $550 a ton, and the potential savings there about $26 million. So all combined, it's somewhere in the ballpark of $50 million, and that's almost enough money for 1 lane mile of concrete pavement. So we're easy. Easy. So, all right. Anyway, so we think in general the asphalt, the HMA recycling, it's been a very successful program. And why is it that there was a lot of innovation back in the 70s, back when I was just starting college, by both industry and agency personnel. They took prudent risk. This was, I think, Sam Joyner mentioned on it. It's not so much DOT folks are lazy as we're averse to risk taking. We don't get rewarded for trying something. If it fails, we don't normally get accolades from the legislature when that happens. So they took prudent risk and it turned out well. We've had good performance. There was good economics in doing this. So it was an economic incentive for both the contractor and the agency to use it. So it was market driven and it's been a very highly successful program. Let's switch gears and talk about our recycled tire rubber program, which that started basically in the 1988 Florida legislature. Although, interesting enough, when I was a co-op, I went to school at the University of Florida, and I co-opted with the DOT, worked in the asphalt lab, and in 1985, I was working on asphalt rubber. So we've been playing around with it for quite a while. But they passed legislation that directed the department to research the use of rubber, and if it was feasible to adopt specifications to use it. Didn't say we had to do it. They said, research it and if feasible, adopt it. So we did it. It took 6 years that time to get it developed. There wasn't a lot of buy-in from industry. We had some pushback with respect to worker emissions and things like that. And again, in this case, the department looked at the benefits as being it conserved resources and it also would improve performance. So here's some numbers. We use it in friction courses and interlayers. DOT usage since '94, again, these are kind of ballpark numbers. We think we've used over 70,000 tons of ground tire rubber, which works out to be 7 million tires. Now, some good cocktail information about tires. The rule of thumb, I think, is somewhere that each person generates 1 waste tire per year. So in the state of Florida, what, 19 million people? That's 19 million waste tires per year. And in roughly 20 years, we've used about 1/3 of that. So we're not having a huge impact on the use of tires.